Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, January 20, 2022, Thursday, 3:40 a.m. मैं सूरज सिंह भारत इंडिया से बोल रहा हूँ। आज दिनांक जनवरी 20, 2022 सुबह के 3:40 बृहस्पतिवार। टॉपिक ऑफ सब्जेक्ट, टॉपिक ऑफ टॉक is same. Gross talk is regarding quality concrete. Quality concrete specifications, title as indicates, you can see on that. Quality concrete specifications, civil field engineering related to life, engineers and contracts, works, methods, and of course institutions or organizations, communication and coordination, as you know, in common we consider every day. Very important issues always, without which life cannot move. It's really very smart talk if we take it in its light spirit, in its real spirit. If we are serious, if we have to understand something out of it, in that case it can be said, this is, as usual I say, my identification, or you can say my title, professional titles, and in fact this is for giving email every day. An email is here, you can see where my cursor moves, Suraj _ engineer at yahoo.co.uk, and also this is my certification valid up to September 2025, and its abbreviated form is INT-PE India and full form is International Professional Engineer India in field of civil engineering, and this is of course Chartered Engineer India in field of civil engineering, and here is fellow membership, that is IEI fellow, in short we call it, Institution of Engineers India, that we call it chartered body in India. And here's quality file, and of course there is concrete terminology file from ACI that we have to confer on, and therefore we can say this is quality file will confer on. I close fellow and I close CE to reduce space on desktop, on my monitor, on my laptop. Title is same, you may say, nothing new in that. You are right, title is same, but deliberations are not same. As I repeat, active quality performing application, or we can say active quality performance. SHE stands for safety, health and environment. And I say engineering approach on designs, manufacturing and construction. Engineering approach, that is. It's very serious issue when we say engineering approach. This means professional approach on every part of project. I am saying project because engineering moves with projects only. Engineering cannot move without projects, and maybe thousands projects in engineering around world, and in our country maybe hundreds every day are dealt with. New projects come and old are completed, or you can say running projects are completed. New projects keep on coming irrespective of size of project. This may be very small projects or medium sized projects or mega projects. Projects are projects. And you know meaning of project. Project and operations are different scenarios. Project is certainly time limited. While operations are not time limited, of course, routine limited, or you can say speed limited. Speed limited in the way that some processes keep on moving permanently every day. Processes are designed well, defined well, and these move well according to whatever engineering it is operated. Controls must work there in manufacturing, in industrial activities, or it may be project activities. But project means it should start on some day and it must finish on other day. This one day and other day has a span of time, and that time we call project duration. You know it very well. I'm just trying to refresh. And when we say operational facility, which already starts once project is finished. At end of project, or we can say when project is finally completed in every respect, it goes to controls of operations, and then project is, you can say, silver lined. Project is declared closed and its operation comes into scene. You can say facility starts working for manufacturing or for processing or whatever it is, industry, or it is residential or commercial, or it is certain plant facilities. Whatever it is, that has no limit. That facility has to work regularly without stop, maybe 24 hours, 7 a day, 24 hours a day, and there's no gap except for shutdown or part shutdown. And maybe it works for 2 decades, 3 decades, 4 decades. It depends on its plan. But there is no stop. That is where a difference can be defined. Difference between project and operational facilities. Project is like a baby. We have to start and deliver it. But operation is not a baby. It is a continuous process. We have to understand this point. If you really want to get into this, I know people understand this. Understanding means you have to see this way. Project is directly proportional to operation, because whatever you do in project, that shall operate or serve facility for coming decades. Your project may finish in 2 years or 3 years or 4 years, maximum 5 years, depends. But that operation shall continue for 50 years, probably 40 years or 30 years. So you can say your scale of 1 here in operation may work 10 there. Has to work for 30 years and to take 3 years on its construction. Let us design 3 years. This means 1:10 is ratio. So your work on project, if it is 1:10 ratio, maybe 1:15 ratio, then it's very important issue. Means my one attempt has to work for 20 attempts or 15 attempts or 10 attempts in operation. Then what does it tell me? What does it order me? What order I have to maintain for this? That is a basic question. I have to scale out my efficiency. And if I don't care for that, what shall be state of that operational organization of that processing plant or that industry? If I don't care in my project of construction or project of design, or you can say design and construction together, this design and construction together we call project. Of course, design project is one, construction project is one, But overall, when we talk of project, this means designs and construction project. This means designs and construction. Also, there is internal limit, design and construction proportionality. As I said, project and operational proportionality. There is design and construction proportionality. It may take maybe 6 months to design, maybe 1 year to design. Now it is computer world, it takes less time. But there was a time when even designs used to take 1 year. Well, leave it aside. Let us say construction takes 3 years. So there is again here 1:3 proportional. So 1:3 proportion is there, and then you can say 1:3 and further 3 or 4 decades. So this sequence of proportionalism tells us what level of responsibility one has to own or a group has to own on project and its construction, project design and its construction, so that we can get quality on project based operational facility. I am saying project based operational facility. One day project has to be closed. It has to be declared closed, and after pre-commissioning, commissioning, testing, successful operation or performance, it has to go to controls of operational authority. And here's what I say we have to be careful about. Our short time work and their long time work. Projects short time work and its processing or industrial long time work. Both have relations. There are relations of survival, safety, workability, processing facility. There are so many safety issues involved. Survival is one, safety is another, standard is third one. Emergency is also there, always there. Therefore, complexities arise. Design is not one branch of engineering based. It's not one discipline based. Design has got many relations to project requirements as well as future requirements, because whatever materials we include on designs and in construction, those measure, those decide efficiency of service, efficiency of performance of whatever project product we deliver. It is also true that in designs and in construction, many disciplines are involved. Many branches of engineering are involved. Domination there remains. We can say, as far as technology is concerned, it may be chemical engineers. As far as structural construction is concerned, design is concerned, it may be civil and structural engineers, it may be mechanical engineers, and from service point, it may be electrical engineers, and of course other supporting engineers. But domination of construction goes to civil. But when we measure, we compare it to operation, there is no domination or no major element from civil engineering or mechanical engineering. Maybe mechanical to some extent, but major operation goes to instrumentation engineers, control engineers, chemical engineers, and like that. I cannot define here everything. We are just considering difference, variations that occur. That's why it says active quality performance application. That comes into play. Safety, health, environment come into play. An engineering approach, we say engineering approach on design, manufacturing and construction, and of course engineering approach post delivery of project. That I did not include here. But that is also engineering approach. Process engineering, production engineering, industrial engineering, instrumentation engineering, testing engineering, you can name one and define. All this come into play during operations, and you can say during operations hazards do happen. Fire hazards, storm hazards, you can say vapor storms, vapor clouds, those also come into play, which vision is kept in view, in our consideration during design and construction engineering. It's very complicated arrangement if you combine everything. It's same thing if you many vegetables together and combine, you can call it a mixed vegetable, same way it's a mixed project. No isolation. No isolation of any branch of engineering except combined engineering, allied engineering you can say, which required allied talk, allied considerations, allied technology, allied ways of working, and we can say ultimately it becomes a combined way of total communication and total coordination. So questions come. As I said, titles are here, various titles like quality. I'm just analyzing a little on quality, on title. I say it is quality. Yes, it is. It's not quality on materials alone. It is quality of total project. It's quality of post project. It's quality of every part of project, every part of engineering that we do. Then I say concrete specifications. Here two meanings come into picture. One is concrete material, other is specifications itself. Reliable everywhere. That is meaning of concrete sometimes. Concentration, you can say, of material, concentration of contemplation, concentration, or you can say intensive study of whatever we require. And then I say civil, I say field, I say engineering. It is that civil, of course, it is for civil public, and civil engineering located at threshold of project life. At threshold of project life, that is civil engineering. And because it is field, it's not civil field alone, it is engineering field, it is, you can say, national field, it is public field, industrial field, construction field, processing field, and designs in all fields, construction in all fields. Therefore, it is field. Civil and field are very small terms here, but have got very wide meanings. Engineering exists everywhere. Everywhere because it's a question of application of mind, application of mental analysis, applications of mental considerations, and of course, all this impact life because ultimately our money goes to these activities, these projects in these facilities. Then when something comes like that, we have to deal with professionals. And those professionals are engineers from every branch, scientists from many branches, and of course then followed by all others. But engineers are directors there. Engineers are decision makers there. And when it happens, this means it is a support from contracts, from various books of contracts, like FIDIC defined red, silver, and white books, and of course OSHA related or other bodies related, safety, health, and environment. All these ride for what? They ride on designs for designs. They ride on construction for construction. They use vehicles like methods, floors like contracts, and of course, when vehicles and floors move, there may be accidents, and those may be called safety related accidents or work related accidents, or they can be called failures in working, or we can say failure in methods, because if methods are not defined, for sure we have no confidence working. That's why I can say methods and contracts are very significant relations. Like designs and constructions are related, methods and contracts are related. Prosecution of contracts implications, we can say execution of contracts cannot be done if we have no description by methods. There would be disputes for sure. There can be disputes in various aspects, not only money, financial disputes. There can be technical disputes. There can be engineering disputes. Those are to be solved. There can be difference of opinions. But difference of opinions should be technological based, it should be logistical based. It's not simply we can say, no, what I say is right. It is to be justified. And that's what we can say. All these organizations which we create from every branch of engineering, from commerce, from all aspects we have to think of. We have to analyze and we have to set all this organization in order and then combine them in certain order. And all that can be done by top subject, though it's not defined, but we can bring into our consideration communication and coordination. Coordination is a kind of word. Coordination is a kind, not just a title of terminology. It's something you can say order. It's a kind of professional order. Communication and coordination are, you cannot define them. Every subject has got this. Every activity in life has got this. If you want to work on activity professionally, then you have to record every aspect, every point where we can retrieve that. Communication record is very important for retrieval. You require, and also communication is directly recorded and it relates to coordination, because coordination is kind of speech, is kind of essay, is kind of technology. You may say, though it's not formal technology, but it is a kind of connection technology, which if you do not perform, if you do not relate, it can cause havoc all time. It can cause mistakes all time. Mistakes and remedial of those mistakes cost time, cost, and cost quality deficiency. Therefore, question remains, quality, where does it exist? Always this question remains. And I say, when I talk of ours means my nation. We can call it ours in English language, O-U-R-S, ours. Ours, and ours is Bharat, India, has to respond to quality, which it has failed in recent decades. It has failed to demonstrate quality, and if you don't have quality, who shall prefer to buy our products? You think quality is not a requirement? If you think that, then I am sure you have some problem in your mind, in your thinking capacity. Quality in engineering is number one. We think with quality starting. If you don't consider quality, then one cannot call itself engineer, because engineering itself is a quality profession. It's a quality world. It gives you good quality, it gives you best quality, and it gives you worst quality. Bad quality, or you can say whatever way you define it, it's up to you. But demanded level of requirements must be met, and that's we can say we meet quality or we do not meet quality. And if we do not meet quality, means we cannot evaluate ourselves, and we don't require anyone else to evaluate us, because we know we are not having quality standards. But it's not a fact. Fact is, standards are available all over the world. We have our own standards. We have our reliance on international standards. So we have. But just on paper you think it is okay. No, it's not okay. It should be on paper, and it should be on real world during manufacturing process, construction process, industrial process, whatever we have, we should move with headlight of quality. And if we do not move that, this means we do not respect ourselves, we do not respect anything. But problem is, I am unable, and I am sure that you too would be unable to find quality. This means we do not know where does it reside. I could not find any home where quality is located. In my beautiful nation, my question then comes, where does quality exist? My answer is, I don't know. I don't know. And if you find, I am requesting you at least to advise me or refer to me, where does it stay. I am talking in general, remember. Note it, I am not talking in particular to one class or other. It's just a reference in general, just with we can say a fire of expression to go to everyone, to burn them so that bad quality is out. That is exactly what my intention is about this talk. I have to find addresses of quality. When I used to study atomic physics during my engineering degree, we were very confused about atomic structure, how to define, how to specify where does one atom or electron live. It was difficult to understand what is required. So our professor explained, address of every electron, neutron or proton is required. He had just to explain how can candidate or student understand what is required. Address is required. And if we have address, we can locate that residence or wherever it is. If we know where does quality exist, then I can refer. I go to this guy and see how that has been maintaining quality, so that maybe if I miss that procedure, I can chart out my way according to that procedure, successful procedure. But unfortunately, I'm not efficient in finding where is located that address. I failed to find that, even trying many times. I could not successfully do my job. Can you find it? Or did you try it? If you have certain relation to that, then you should do it. Because maybe you are engineer, maybe you are not, it doesn't matter. Even if you are industrialist, or you are operator, or whatever you are going to sell your product. With confidence you have to sell, or with just equality of confidence you have to sell. It's your choice. It's your product. You are charging, you are giving warranty, you are giving assurance. And if that does not work after product is sold, then you should know what will happen. There have been cases that products were withdrawn in many countries because these did not meet required standards. It should not happen everywhere because we deal with construction. We deal with construction products. We deal with permanent products that have to work for decades to come or even for centuries. So we have to be very analytical in this case of construction forever. We can say construction forever. It's an important part. We have to be very serious in this regard. And if we are not serious, I'm sure we miss a lot. We miss a lot, certainly. We don't want to miss, but we miss a lot in that case. That's why I say it's very important that my titular question is, where does quality exist? And my saying is, could not find, unfortunately. Did you find, or can you find for deliberations? I present myself to you for purpose of conducting deliberations. And I can call it red lines. Red lines. It's not red light, it is red lines. Red light changes to amber and to green very fast, or it even works as indicator of crossing when these three lights don't work. But here I'm calling it red lines, and red lines means a lot. Lines are stopped and impression of red is very strong. Certain red lines that must be turned green. I discussed yesterday also in the last talk on January 19th, 2022, and today following talk January 20, 2022. Worsening state of quality of concrete and how to improve such mandated quality to certain minimum required marks. Material, we call it. Material. Most required material in beginning of whatever we do in title of project and cover of project, that material is very significant for purpose of designs and construction. And it is everywhere like that. Everywhere. And that is called concrete material, composite material. Composite because many ingredients are mixed together. These ingredients convert to very strong product once it is cured properly, and when it gets strengthened according to standard, that concrete product, you can say it's like a rock. It's like rock. But Why I am raising this issue of concrete? This is very important point. Concrete is very strong material, very costly material. It is durable material. It works forever, you can say. If we consider our lifetime, it works forever. And forever means until 1 or 2 generations go out. It cannot complete its work in 1 generation. This point we have to keep in mind if you want to value this product. Don't take it as if you buy some shoes or some socks or some clothes or some vegetable or some food grains or some other item, for example a car. We cannot compare those products to concrete because concrete is better as long as it works, and we call that better status in terms of durability. Its properties, its functions should continuously work for entire life. Even if designer goes off, even if designer passes away, contractor passes away, but these products have got no relation with these professionals. These products are natural or artificial stone, you can call concrete, or it is whatever it is. It's power of our development. Concrete can be defined a power of development because it is used all over the world. Even if we don't construct concrete buildings, we construct steel buildings, structural steel buildings. In that case too, concrete is used in foundations. There is no limit of use of concrete. Concrete is an evergreen material that can be molded into whatever shape, whatever framing, whatever infrastructure. And I think it works everywhere. It works everywhere. And that point we have to take into consideration, and we have to discuss about worsening state of this significant material. And if it is really worsening state, how to improve such mandated quality to certain minimum required marks. I'm sorry. We cannot take everything for granted because there is no use of, if we take everything for granted, then what was purpose that we got education? What is purpose that we are working in engineering if we do not value it? Don't forget that when we work, we involve ourselves with projects or with development, we have to depend on natural support. We have to depend on concrete ingredients. We have to depend upon soil. We have to depend upon rocks. We have to depend upon water and air. We have to depend upon sunlight. There is no one, no two. There's a chain of natural resources. These are all resources. Rocks, stone, dust, sand, water. All are these resources, and they at certain time work as chemistry based sources, chemical reactions work among coherence of these materials, these ingredients, which we call product of concrete. Therefore, we have to think it very differently, that we respect its long-term requirement, every product's long-term requirement, which we can say it is durability, which means long-term requirement with at least given performance performance property of every ingredient or whatever material we have. We have stone, we have aggregate, we have complete concrete solidity, we have other products related to soil and soil itself, and also all other product. Even if you use plaster, it's got natural input of lime, cement or stone dust. Same way, whatever product we use, we have to relate to nature. Even sometime wood was used, timber was used, that too was natural. So we cannot do anything without potential given to us by nature. Or when we say nature, this means there is some power in nature that controls all these properties, all this wealth given by nature. And we too, as person, as engineers, are wealth from nature, because we have mind and we got education, and that education must be respected, must be honored in terms of without thinking of having lot money because we do projects. Our only ambition is how to have good working quality, or quality that is defined and that is required, even if it is not defined conventionally or naturally or property wise. It is effective, it remains effective. If it falls from its standards, it falls not because of natural deficiencies, it falls because of our attitude, because of slackening attitude of professionals or occupational forces, I mean to say workers. They should understand what quality is and what quantity is. All these should understand. These engineers, these technicians, these foremen, these may not be formally, academically qualified, but if they are given good references or they are taught, then this talking or this teaching, this coaching should continue for as long as possible, for purpose of imparting skills development everybody. That's why I'm saying, if you want to raise our quality, it may be bad, it may be good, whatever it is, you have to bring it up to certain level where we can say our product is international product. That is, we are not so serious about to get in. So we can say improvement is more important, and the improvement point is individual approach. Worsening state of communication and cost coordination during working on engineering designs, it is executions or construction activities. It is no secret that communication and coordination are very significant tools, very significant, you can say, weapons of private ownership, that we can use this skill of communication and coordination, and which in our country about 98% people, or even 99% people, are not serious about. They are not serious about because they are not used to that kind of background in their childhood. So we can say individual attitude, engineer attitude, individual attitude, workers attitude, industrial attitude, owner's attitude, or you can say client's attitude. All these attitudes are clubbed together and then connect to work together. Only then we can open our eyes and minds. If we keep something in mind while learning, this way or that way, that stage is very significant. If you can do it efficiently, if you say no, I cannot do efficiently, it will take time, that's very difficult. You cannot lose time. How to improve such some mandated quality to certain minimum required marks? That is very brilliant question, because ultimately we talk of marks. It's not formal marks, it should be real marks. And we say, if I miss to even read and write or to communicate to someone, then it shall become very difficult for me and for that proposed teacher to work together. To an extent, quality is related. We have to be real world, real people. Communication and coordination, though sometimes it takes time, but it is wonderful that every act is clear. If maybe I miss something, then I have to know it from someone else, or have to raise my problem with someone, whoever is responsible for that issue, to decide. So as I say, communication and coordination during working on engineering designs and executions or construction activities amount to solid requirement, amount to indiminishable requirement, and its requirement, and if you know what has to be done by whatever way of experience or by whatever of explanation or by data sheet of certain work, we have to examine validity of that work. Here it's not important whose name is there on some requirements. Importance is that we have to apply those restrictions. We have to apply good act, good provisions on works. Here, when we have to handle communications, we have to handle coordination. This means we have to handle a lot. Here, what comes into this responsibility? What comes into ownership of this responsibility and obligation? And here comes in professional who is named civil engineer. Civil engineer is not a designation only. It's not a professional designation. It's something that we have to realize shortly. Role of engineers towards realizing these requirements, and if we decide role of engineers accordingly, then question comes, do we have? That is, can we do it, or we are incompetent? We are incompetent and inconsistent societies or groups, and we cannot commit anything. And if I say commit, that is different line. We have to commit. And commitment is quality commitment, quantity commitment, both commitments which can be clubbed together. So we can say quality and quantity cannot be separated physically. That's a very important point. We are engineering force. We are consistent people. We are competent people. We always say that. We always claim that. We do not think too much for others. Are we engineering force or incapable lot? That question also we have to concentrate on, and then we have to coordinate what we talk about. That coordination and that communication should not be just superfluous. It takes time, so we have to to your time. It's myself or someone else who think of this nation. They think contents of this nation. If we cannot do that, if we cannot communicate properly to ourselves, to others, and we cannot coordinate accordingly, then my question is, we have to find solutions from every question. We are forced or we are not forced, that also we have to chart out. And as far as I consider, engineering is a force. Engineering is a force. And if it doesn't, who is there? Engineers means qualified people. They know what should be done. Yes, maybe they have not done it, but even very small street person can do it itself. That is where we have to talk of interest and all that. That question here is very interesting, and we have to be very clear about that. I'll put off switch now because it's fully charged, and I'll put off for say half an hour so that battery is not impacted by. It's also a part of quality process to enhance life of battery. Questions shall remain always. Questions shall keep coming and answers moving in. This is process. This is a process of contemplation, process of thinking, process of working, deliberations. And only problem is we have to speak to ourselves. We have to speak to ourselves. That is really very important requirement. And these red lines force us to think. Important point also lies in that engineers can think a lot. There is no doubt about that. Engineers can think a lot, but they don't speak. They don't speak, and there may be reasons for that. But if you think in interest of work, if you think in interest of long term, we cannot think in interest of honors of that work, but honors of work itself, honors of project itself, and that honor is use of product, is quality of product, durability of product. Product should work for duration as much as possible, more than demanded one. And for that, even if we have to retrofit or we have to upgrade project in designations of brownfield project, it must be done. It's mind that thing. It's our approach that forces us to think. It's a very important point. So we say, who shall decide about all such questions that are being faced in current scenario? Who shall decide? I think there is a self answer. There is a self approach towards this, and we do not have to find who shall decide. Because if we find who shall decide, it is for ourselves. It's myself on my work. It is yourself on your work. Who otherwise shall decide? Worker shall decide. And engineer is worker number one because of policy, because of designs, because of cost, because of intellectualism. All this lead to good product. Which point We cannot overrule. My personality may not be good. I'm not interested in that. I am interested in my work, my contribution towards that product. That is sole requirement. My face is not important. My role is important. And that role is role of engineers or engineer's role, and that role means total personality. Efficiency, proficiency, time economy, cost economy, quality economy. You can say, okay, you do not want to give value added quality, no problem. Value can be added later, but at least give demanded or mandated quality. In a start, that would work. In a start, that would work. Maybe I'm not that much efficient to get value addition immediately, but at least work has to move in its required standard, in its minimum standard. So we can say, all right, what you have to do? Although there's a system, of course, there's a system. In designs, there's some system. In construction, there is some system. In maintenance or operations, there are some systems. If systems have or have been charted out, these are based on mindset. We cannot simply take one part of these. I cannot simply say, okay, I worry about finance, I don't worry about other factors. I have to keep cost in control only. I don't care about other factors. This means we are not professionally oriented. We don't know that these factors correlate with each other. And if you do not consider that, we do not value our supermaster, superpower. What comes into play, which road we have to go, which track we have to follow, and that track we can say is contracting. Contractor, we say, contractor means two persons who work together on same project. Both may be from different background, from different apprenticeship, and maybe from different professions. But when they work together, they consider responsibilities are combined and they are qualified, experienced engineers, or maybe if not experienced, they may be learning towards that attainment. It's also true, it's not only formal education I'm talking total education, which can be procedural job means procedural job. We have to prepare for that once our work is completed. We have to think that way. We have done this project in room, but this is to be installed and then tied up. It's where we have to stand. What do you say? There is a road. I say yes, there is a road network, and that road network is called contract. Contract. You think contract is just a spelling, just a word? That's not true. It's not true. What we say, what about contracts for construction? What about contracts for designs and construction? Or we call it construction contract, or engineering procurement and construction contract, or some other kind of light contract, not very heavy contracts, which are supplies contract, or which are similarly some other pattern related contract. And contract is a total responsibility, though because we say it's contract, of course we have contracting responsibility, and when it comes to performance of engineering product, this contract is professional contract. Professional, not even occupational. And we have to have different approach. We have to move with different requirement, with different consideration, a different scope of work on such contracts. These contracts are not, sales or purchase contract. These are professional contracts, and we can say engineering professional contract. When we say construction contract, this means engineering construction contract, engineering design contract, or design services contract. These are very heavy, honorable terms, because without specialized activities of such title, where construction designs and all other projects are involved, those projects create this momentum that we have to deal with contractor and contract, and then further notified documents. Therefore, it's very easy. It's important and it's of utmost significance that we should keep in mind engineering is not just a document. It's not just some instructions given to you during few couple of months, I can say not years, during your education. But maybe we do not respect that. But once we come into engineering, which itself is a calculation world, it's the world of errors, world of truth, then we can say, yes, it's my duty to continue this talk at some other time. But we have to understand what we have to talk. Contract is very powerful word. Contract defines each and every requirement. There is no schedule of rates. There is no such document which we can copy and paste. It takes time, of course, but don't forget, once you do it, you have coordination of these processes in your home. That's the reason I always question, what about contracts for construction? And you have to answer it. What about contract for construction? And what about EPC contract? What about EPC contract? That is resolving some problem with some considerations, with some statements, or you can say you have to rely on them. You have to rely on them. Contract has to be understood clearly. It has to be defined clearly. When clearly comes twice, means your thinking goes on in same direction. Therefore, we have to concentrate on this also. What is quality contract? What is quality contract? We say, do we design, or sorry, do we organize? Do we organize to design quality contract, or do we go per lines decided by others? Should we ignore power and impacts on works and quality performance that contracts can attack on design prosecution? Do we organize to design quality contract, or do we go per lines decided by others? Should we ignore power and impact on works quality performance that contracts can attack on designs prosecution? Why I'm stressing contract? If we have, it has to work. It has to work appropriately. When I say contract, this means responsibility. It's not one person, it's not two person. Now we are talking of some group of people, group of personnel. Design quality contract. What is quality of contract? Can you answer? Quality of contract. I'm just thinking on what should be quality of contract. Should we not do that? Or we just take a standard form and say, I sign this and you sign this. Is this okay? I think no. Quality of contract is very significant because it affects on every aspect. If you cause problems in contracts, then contract shall be thrashed like anything, though it can't be thrashed. But we have to face problems because of abusive clauses of contracts. We have to realize this fact. We have to realize this fact. What is quality contract? Quality contract means, first of all, it has to be clearly clear. It has to be given a standardized position. It's not that I do not know something, I should get it. It happens. It happens. Nobody can say no. How do we understand quality? If you are not involved in contracts, you cannot understand it. You have to involve. We have to see all conditions. First of all, that they should be in sequence. They should concentrate on scope of definition of work. Scope within definition of work. So that we have clear idea where we mention, do we get it? Or we can write it. We can write a refer to specifications. And do we know where are specifications? That's what I say. To know all this, to know all complete family contract, then we have to think a lot on purpose of consumption or rating. Quality contract means contract should be clearly detailed out. We have to see that we can use our knowledge into framing sequential contract to start with name, etc., scope, and then we have to define which materials are best suited for our knowledge. Quality contract is very important structure for everybody. First of all, it links ourselves to sequence. Quality itself is very important in contracts because contracts should not be mixed up. What is purpose of contract here? Our purpose is that this construction should be done qualitatively in time and cost. Time and cost we put in cup and we write there on walls, and after 10 minutes or some other time, maybe 1 hour, maybe 2 hours, depending on temperature and weather. Such times are very important, very significant. An engineer has to think that way. How you have to move project, that way your contract should move. Contract should be clearly defined without any errors, and we have to follow up, we have to lead ourselves, we have to decide sequences are right or not. If you read sequences in FIDIC, you will find it starts with original requirement, and then its final requirement comes. It simply says next time. Okay, next time, no problem. But I say, do our engineers have interest in contract design quality? Contract design quality. And my delegation to this is that no. We come to next point in contract. Should be in sequence, it should be in sequence. It should be sequence as much as possible. An engineer has to understand this. It's not simple technical work, it's also technical work by the engineers. Contract is a technical requirement. Because it is used in construction, it is used in EPC. If you are not EPC oriented, you are construction oriented. You have to be very smart in that. Have to be. So art our engineers on contract performance and contract related disputes? They're happy with. Do we involve? We are inclined to involve, or we are not inclined to involve. You can say construction contracts. Or we'll leave it to others. We'll see, we'll decide later on. Is it affordable in construction? In construction contracts, we cannot ignore requirements. We cannot ignore right speed. We have to decide time duration, and based on that time duration, we have to decide how we have to move. And of course, we cannot postpone sequence requirement by client. That also requires first preference, what it is. What is issue of engineers? What is issue that engineers do not incline to work in coordination activities that impact on quality of designs and quality of construction? See, it's not simple. It's not that simple as we think. It's a complicated one, and it is intelligent one as well. We cannot leave it to grants. We cannot leave it to chances. We cannot leave it to opportunities. No. You see, it is like requirement. Food. If I want to eat food, I can't say I have eaten. I can't simply imagine that I have eaten. It has to be available. It has to be produced. Only then it can be eaten. That point must be made very clear, that something is positive, something is physical. We cannot say no. It has to be, and it has to be. That's what I say. What is issue that engineers do not incline to work in coordination activities that impact on quality of designs and quality of construction. And I say, should we respect contracts or we should move without contracts? These points are very worrying, and if I say that why do we keep off communications and coordination? Its answer is very, very simple. I'm not saying it's general. Some people have very good coordination skills, communication skills. In engineering also, we have people, but that is, minimal. That is not general. That is not general. When I say communication, it's not alone contextual, conditional communication. It's communication about work. Communication about work, and this communication is very much starts with original work, physical activity. Sometimes we say, you speak 1,000 words, it doesn't have any meaning. And if you just give simple sketch to someone, that person can understand what is required, what is need, what is essential, what is necessary. All that happens. This means it is also communication to use certain diagrams. It's also a part of communication to tell someone what to do, or to give in writing, you have to do this, or this is our line of action. This is stratification of sequences that we can say. But that requires work, homework, or we can say preparatory works. Preparatory works, we can say this one. We have to prepare for examination. And remember, every project weighs examination. Whenever we do work, we submit ourselves to examination. We submit ourselves to examination, and who examines? Product user examines, product examines. We are examined on quality of product, efficiency of product, performance of product, and how much percentage of requirements that product delivers. Is it efficient or it is not efficient? Is it bearable or not bearable? It is replaceable or not replaceable? We have to worry about this. Replaceable. If people say this product is not working, there is only one option: to replace it or to modify it. And replaceable or unreplaceable is admissible in certain branches of engineering, not in every branch of engineering. And for example, I can say in construction engineering, in civil engineering, replacement is remotely located. So we cannot exclusively depend on replacement also. Replacement can be agreed in machines or in some other systems, or you can say in computers. But if you say replacement in construction engineering or in civil engineering, I think it's very unrealistic. We cannot replace that. We can replace some machine part immediately, or we can even replace whole machine. It is not big deal. But replacing permanent concrete or replace something else like that, we cannot bear with. We cannot bear with. I'm not trying to explain you like kids, but because we forget, that is tendency, we forget. There's nothing specific in that, we forget. We have to be serious about that issue. Already it's long distance talk today. I don't want to bore you on this. We'll leave it here for next time. And now we jump to other aspect. Other aspect of our documentation, how we say, that is concrete terminology, where we were available. We referred to that one last time, and maybe we could not move whole page, but now we are going to that one for sure. And we said, we discussed many terms on page 60 here, or which page we was. I think I had to go further on this. Sheathing, sheath pile, shielding concrete, shim, and we can say, I think, shrinkage reinforcement, systematic international, shrinkage compensating cement, sieve analysis, silica fumes we discussed, and also side form slip, slump, discuss slump also, snap tie soil pressure, soil masonry wall, and solution soundness, spacer, spacing factor, filio factor. We have somewhere spatter dash, specialty structural engineers, and specific surface, specifier specimen, spinning spiral split face block, splitting tensile strength, spray drying. So we say, I think, specifier specifies compressive strength, specified compressive strength, concrete equivalent strength. So we say, let us say we start here with specialty structural engineer and specific gravity we did. Alright, so we say spatter dash we did in plaster, spandrel beam we did, and spatter we did. So we can say spandrel beam, we said span depth ratio, effective span, spalling span. So spadding, spreader we did, spacing factor. Let's do this now. An index spacing factor, an index related, what spell is left, 69%. Space is a spacing factor, what spell is left, 69%. Space is a spacing factor, index related to maximum distance of any point, maximum distance of point in a cement paste or in cement paste fraction of mortar or concrete from periphery of an air void. This is spacing factor, an index related to maximum distance, an index related to maximum distance of point in a cement paste, any point in a cement paste or in cement paste fraction of mortar or concrete from periphery of an air void, also called Powers spacing factor, filio factor. To establish index related to maximum distance of whatever point in cement paste or in cement paste fraction of mortar or concrete from periphery of an air void. That is actually atomic power we are talking, internal structure we are talking, spacing factor. And spading is consolidation of mortar. Consolidation of mortar or concrete by repeated insertion and withdrawal of a flat spade-like tool. Spading is consolidation of mortar or concrete by repeated insertion and withdrawal of a flat spade-like tool. Spall, a fragment, usually in shape of flake, detached from a larger mass by a blow, action of weather, pressure or expansion. Within larger mass, spalling, development of spall. So spall is a fragment, usually in shape of flake, detached from a larger mass by a blow, action of weather, pressure or expansion within larger mass. And spalling is this process. Span is distance between supports, distance between support reactions of members carrying transverse load. Span length is effective span. Effective span. Span length is effective span. Span depth ratio, numerical ratio of total span to member depth. Spandrel, that part of a wall between head of a window and sill of window above it. Spandrel beam, a beam in perimeter of a building spanning between columns and usually supporting a floor or roof. Spatter dash, rich mortar, or you may say rich mixture of Portland cement and coarse sand thrown onto a background of a trowel, scoop or other appliance to form a thin, coarse, textured, continuous coating as a preliminary treatment before rendering it. Assist bond of undercoat to background, improves resistance to rain penetration and evens out suction of variable backgrounds. A specialty structural engineer, licensed design professional retained by a contractor or specialty subcontractor to design a delegated portion of project. Delegated portion of project. A specific gravity factor, ratio of mass of aggregate, including moisture of course, as introduced into mixture, effective volume displaced by aggregate, and a specific heat, amount of heat required per unit mass to cause a unit rise of temperature over a small range of temperature. A specific surface of particles or of air voids, surface area of particles or of an air voids contained in a unit mass or unit volume of a material. A specification is the explicit set of requirements to be satisfied by a material, product, system or service. A specified compressive stress. A specified compressive strength of concrete used in design. Specified concrete compressive strength. Specified resistance of a concrete specimen to axial compressive loading. Axial compressive loading used in design calculations and as basis for acceptance of concrete used in work. Specified concrete equivalent strength. Specified concrete equivalent strength in place concrete compressive strength adjusted by correction factor that can be directly substituted into conventional strength equations within or with customary strength reduction factors. I repeat, specified concrete equivalent strength, in place concrete compressive strength, in place or in situ concrete compressive strength adjusted by correction factors that can be directly substituted into conventional strength equations with customary strength reduction factors. Then specifier, a person or entity preparing specifications for a material, product, system or service. Specimen, a piece or portion of a sample used to make a test. Spinning means essential factor of process of producing spun concrete. Spiral reinforcement, continuously wound reinforcement in form of cylindrical helix. Spirally reinforced column, a column in which vertical bars are enveloped, a column in which vertical bars are enveloped by spiral reinforcement, sorry to slip of tongue, a column in which vertical bars are enveloped by spiral reinforcement. Splice, a connection of one reinforcement bar to another by lapping, that's number one, lapping or welding or mechanical couplers or other means. Also, connection of welded wire reinforcement by lapping, that is welded wire fabric, you can say. These meshes generally square and a half are lapped or square lapped, and also connection of piles by mechanical couplers. Split face block, a concrete masonry unit with one or more faces purposely fractured to provide architectural effects in masonry wall construction. Splitting tensile strength, tensile strength of concrete determined by a splitting tensile test, also called indirect tension strength. Splitting tensile test. Before was splitting tensile strength, and this is splitting tensile test. A test for tensile strength in which a cylindrical specimen is loaded to failure. A test for tensile strength in which a cylindrical specimen is loaded to failure in diametral compression applied along entire length. That is a test for tensile strength in which a cylindrical specimen is loaded to failure in diametral compression applied along entire length, also called indirect tension test. Spray drying. Spray drying, a method of evaporating liquid from a solution. A method of, I am talking of spray drying, a method of evaporating liquid from a solution to or dispersion by spraying it into a heated gas. Spray drying is a method of evaporating liquid from a solution or dispersion by spraying it into a heated gas. Spray drying. method of evaporating liquid from solution or dispersion by spraying it into heated gas. Sprayed concrete, European terminology for shotcrete. Sprayed concrete, European terminology for shotcrete, concrete placed by a high velocity pneumatic projection from a nozzle. Sprayed mortar, low velocity sprayed mortar, low velocity, low pressure, spall repair, spray using pre-packaged mortar. Spread footing. Spread footing, a generally rectangular prism of concrete larger in lateral dimensions than column of a wall, column or wall it supports, to distribute load of a column or wall to subgrade. Spreader, a piece of lumber approximately 25 by 50 mm cut to thickness of a wall or other formed element and inserted in form to hold it temporarily at correct dimension against the tension or form ties. A device consisting of reciprocating paddles, a revolving screw or other mechanism for distributing concrete to required uniform thickness in a paving slab. A device consisting of reciprocating paddles, a revolving screw or other mechanism for distributing concrete to required uniform thickness in a paving slab. Spud vibrator, a vibrator with a vibrating casing or vibrating head used to consolidate freshly placed concrete by insertion into mass. Spun concrete, centrifugally cast concrete, stacking tube, a slender free-standing tubular structure used to store granular materials. Material is loaded into top of tube and spills out of wall openings to make a conical pile surrounding tube. Stain, use of chemical stain or a concrete dye to change color of concrete surface. That can be a penetrant or a low build coating that does not appreciably change concrete's textures. Tamping, process of applying a surface pattern to decorative concrete by using impact pressures to emboss texture, pattern or fox joints into surface of plastic concrete. It is tamping, as maybe somebody calls stamping. So force process of applying a surface pattern to decorative concrete by using impact pressure to emboss texture, patterns or fox joints into surface of plastic concrete. standard curing, exposure of test specimens to specified conditions of moisture and temperature, standard fire test prescribed by STM 1E119, then standard hook, a hook at end of reinforcing bar made in accordance with a standard hook bar, a reinforcing bar with end bent into hook of prescribed geometry to provide anchorage, standard sand, silica sand used for preparing mortars in testing of hydraulic cement. Standard sand, silica sand, composed almost entirely of naturally rounded grains of nearly pure quartz used for preparing mortars in testing of hydraulic cements. Silica sand, composed almost entirely of naturally rounded grains of nearly pure quartz used for preparing mortars in testing of hydraulic cements. Standard time temperature curve, graphic timetable for application of temperature, to material or member for fire test. Static load, mass of a single stationary body or combined masses of stationary bodies in a structure, such as load of a stationary vehicle on roadway. During construction, combined mass of forms, stringers, joists, reinforcing bars, and actual concrete to be placed. Static modulus of elasticity. Static modulus of elasticity, percentage wise it is not much. It is 49 minutes. Still we have time. Well, static modulus of elasticity. Let me wear shoes. I'm getting cold leg. This problem is sitting without. This cold weather is my non-resistant. I can't resist it. This is a static modulus of elasticity. Value of Young modulus of elasticity. Value of Young's modulus of elasticity obtained by arbitrary criteria from measured stress-strain relationship derived from other than dynamic loading. Stationary hopper, a container used to receive and temporarily store freshly mixed concrete. Steam curing. Curing of concrete, mortar, grout or neat cement paste in water vapor at atmosphere or high pressure and at temperatures between approximately 40 and 215 degrees Celsius. That is atmospheric pressure, steam curing, pressure steam curing, and autoclave curing. Stearic acid, a white crystalline fatty acid. A white crystalline fatty acid obtained by saponifying tallow or other hard fats containing stearin. Steel sheet, cold formed sheet or strip steel shaped as a structural member for purpose of carrying live and dead loads in light lightweight concrete roof construction. Steel trowel stove, stencil patterned concrete. Texture created by use of pre-printed pattern stencils or freedom or free form using alternate texturing materials. Step footing, a step-like support consisting of prisms of concrete of progressively diminishing lateral dimensions superimposed on each other to distribute load of a column or a wall to subgrade. Sticky cement, finished cement that develops low or zero flowability during or after storage, in silos or after transportation, in bulk containers or hopper bottom cars, may be caused by interlocking of particles, mechanical compaction or electrostatic attraction between particles. We have here then stiff back, strong back. Stiffness, resistance to deformation. Resistance to deformation is called stiffness. We can say stirrup, bar or wire reinforcement oriented normal to or at acute angle to longitudinal reinforcement in a flexural member and extending as close as practical to extreme tension and compression fibers of cross section. Stoichiometric, characterized by being a proportion of substance energy in a specific chemical reaction in which there is no excess of any reactant or product, proportioning based on atomic or molecular weight. Stone sand, fine aggregate resulting from mechanical crushing and processing of rock. Storage hopper, stationary hopper, straight edge, rigid, straight piece of either wood or metal used to strike off or scrape a concrete surface to proper grade or to check plainness of finished grade. Highway tool for truing surfaces instead of a bull flat. Straight line theory, assumption in reinforced concrete analysis according to which strains in a member on the flexure are assumed to vary in linear proportion to distance from neutral axis. Strain change in length per unit of length in a linear dimension of a body. Strain hardening. Strain hardening, ability to carry increasing tensile strength, tensile load beyond point of first crack. Strain softening, ability to carry a reduced but non-zero tensile load, ability to carry a reduced but non-zero tensile load beyond point of first cracking. Strength, a pre-stressing tendon composed of numerous wires twisted around center wire or core. Ordered assemblage of filaments of predetermined quantity based on number of filaments per stand that have a high ratio of length to diameter are normally used as unit, and they're bundled together to resist splitting or filamentation. Strength wrapping. Application of high tensile strength wound under tension by machines. Applications of high tensile strength wound under tension by machines around circular concrete or shotcrete walls, domes, or other tension resisting structural components. Strength wrapping it is. Strength wrapping. We have stratification. Stratification we have discussed. Separation of overweight or over vibrated concrete into horizontal layers with increasingly lighter materials towards top, water, lathens, mortar, and coarse aggregate tend to occupy successively lower positions in that order. A layered structure in concrete resulting from placing of successive batches that differ in appearance. Occurrence in aggregate stockpiles of layers of differing grading or composition. A layered structure in a rock foundation. Straddling compounds. Dicalcium aluminate, monosilicate, 8 hydrate, a compound that has been found in reacted lime pozzolan and cement pozzolan mixture, that is dicalcium aluminate monosilicate. Strength, a generic term for ability of material to resist strain or rupture induced by external forces. We have a strength design method. Strength design method. A design method that requires service loads multiplied by load factors and computed nominal strengths. We multiply the strength reduction factor. Stress is force per unit area. Stat corrosion of metal either initiated or accelerated by stress. Stress relaxation, time dependent decrease in stress in a material body, in a material held at constant strain. Stressing end. In pre-stress concrete, end of tendon at which load is applied when tendons are stressed from one end only. Stress station diagram. Stress strain diagram. A diagram stress strain diagram in which corresponding value of stress and strain are plotted against each other. Stretcher, a mass unit laid with its horizontal and parallel with the face of a wall. Stretcher is a masonry unit laid with its length horizontal and parallel with face of wall or other masonry member. Strike off, to remove concrete in excess of that which is required to fill form evenly or bring surface to grade. Performed with a straight edged piece of wood or metal by means of a forward sawing movement or by a power operated tool appropriate for this purpose. This is also called named applied to tool. A stringer, a secondary flexural member that is parallel to longitudinal axis of a bridge or other structure. Strip, to remove formwork on a mold. A long thin piece of wood, metal or other material. Strip foundation, a continuous foundation wherein length considerably exceeds width. Stripper, stripper stripper a liquid compound formulated to remove coatings. A liquid compound formulated to remove coatings by either chemical action, solvent action, or both. That's called stripper. And stripping, removal of formwork or a mold. Demolding can say strong back, a frame attached to back of a form or precast structural member to stiffen or reinforce form or member during concrete, placing operations or handling operation. Structural adhesive, a bonding agent used for transferring required loads between adherent exposed to surface environment, typical for structure involved. A bonding agent used for transferring required loads between adherents exposed to surface condition environments, typical for structure involved. Structural concrete, plain or reinforced concrete in a member that is part of structural system, required to transfer gravity loads, lateral loads, or both along a length load path to ground. Structural end point. Acceptance criteria of code ASTM E119, which states that specimen shall sustain applied load without collapse. Structural lightweight concrete. Structural concrete made with lightweight aggregate and having an air dry density of not more than 1850 kilogram per meter cube. Structural load test procedure consisting of applying loads to verify and load carrying capacity. Procedure consisting of applying loads to verify load carrying capacity of a structure or structural member. Structural repair, a repair that re-establishes structural lightweight concrete, structural load test, procedure consisting of applying loads to verify load carrying capacity of a structure or structural member. Structural repair, a repair that re-establishes or enhances structural capacity of a member. Repair that re-establishes or enhancing structural capability of member. Structural sandwich construction. structural sandwich construction. A laminar construction. A laminar construction comprising of a combination of alternating dissimilar, simpler structural sandwich construction. Structural sandwich construction, a laminar construction comprising a combination of alternating dissimilar, simple or composite materials assembled and intimately fixed in relation to each other so as to use properties of each to attain specific structural and thermal advantages for entire assembly. Structural sandwich construction, laminar construction. Laminar construction comprising a combination of alternating dissimilar, simple or composite materials assembled and intimately fixed in relation to each other so as to use properties of each to attain specific structural and thermal advantages for entire assembly. Strut is shore, strut and tie model. A framework, strut and tie model, a framework or truss model of a structural member or of a D region in such a member made up of struts and ties connected at nodes capable of transferring factored loads to supports or to adjacent B regions. Stub wall, low wall, usually 100 to 200 mm high, placed monolithically with a concrete floor. Low wall, usually 200 mm high, placed monolithically with a concrete floor or other members to provide for control and attachment of wall forms. Also called kicker in United Kingdom. Stub wall. Stucco, a Portland cement based plaster used for coating exterior walls and other exterior surfaces. Stucco, Portland cement based plaster used for coating exterior walls and other exterior surfaces. Stud, member of appropriate size and spacing, member of appropriate size and spacing to support sheathing of concrete forms. A headed steel device used to anchor steel plates or shapes to concrete members. Subaqueous concrete. Subaqueous concrete. Underwater concrete. Subbase. Layer in a pavement system. Layer in a pavement system between subgrade and base course or between subgrade and pavement. Subgrade, soil prepared and compacted to support a structure or a pavement system. Subgrade modulus, coefficient of subgrade reaction. Subgrade modulus is coefficient of subgrade reaction. Subgrade reaction, contact pressure and coefficient of subgrade reaction. Substrate, material on surface of which another material is applied. Material on surface of which another material is applied. Substructure, substructure, part of a structure below grade. Sulfate attack, a chemical reaction, physical reaction, or both between sulfates, usually in soil or groundwater, and concrete or mortar. Sulfate resistance, ability of concrete or mortar to withstand sulfate attack. Sulfate resistant cement. Portland cement, that is low in tricalcium aluminate. Portland cement, that is low in tricalcium aluminate, to reduce susceptibility of concrete to attack by dissolved sulfates in water or soils. Refer to STM C150, C150M type 5 cement. This is type 5 cement. Sulfo-aluminate cement, type K expensive cement. Superimposed load. Superimposed load. Load other than its own weight that is resisted by structural member or system. Superplasticizer, high range water reducing admixture. High range water reducing admixture. Superstructure, all part of structure above ground, above grade. Supersulfated cement, hydraulic cement made by intimately intergrinding a mixture of granulated blast furnace slag, calcium sulfate and a small amount of lime. Portland cement or Portland cement clinker, so named because equivalent content of sulfate exceeds that for Portland blast furnace slag cement. So hydraulic cement, super sulfated cement is hydraulic cement made by intimately intergrinding a mixture of GGBS, calcium sulfate, a small amount of fine or small amount of lime. Portland cement or Portland cement clinker, so named because equivalent cement or Portland cement content of surface sulfate exceeds that for Portland blast furnace slag cement or or Portland cement, equivalent cement content of surface exceeds that for Portland blast furnace slag cement. Let us say again supersulfated cement, hydraulic cement made by intimately intergrinding a mixture of granular glassman slag supplementary cementitious material, inorganic material such as fly ash, silica fume, methylene, or slag cement that reacts pozzolenically or hydrolytically. That reacts pozzolenically as well as hydraulically. Supplementary cementing material, inorganic materials such as fly ash, silica fumes, methacholine or slag cement that reacts pozzolenically or hydraulically. Surface active, having ability to modify surface energy and to facilitate wetting, penetrating, emulsifying, dispersing, solubilizing, foaming, frothing, and other substances. Surface active definition: ability to modify surface energy and to facilitate wetting, penetrating, emulsifying, what we say, you can say surface active, having ability to modify surface energy and to facilitate wetting, penetrating, emulsifying, dispersing, solubilizing, foaming, frothing, and other substances. And here, surface air voids, small regular or irregular activity, small regular or irregular cavities, usually not exceeding 15 mm in diameter, resulting from entrapping air bubbles in surface of formed concrete during placement and consolidation. Surface area is specific surface bonding of masonry, bonding of dry laid masonry by barging with thin layer of fiber reinforced mortar. Bonding of dry laid masonry by barging with thin layer of fiber reinforced mortar. And surface moisture, free water entered, free water retained on surface of aggregate particles Water retained on surface of aggregate particles and is considered to be part of mixing water, considered to be part of mixing water in concrete, as distinguished from absorbed moisture. For this surface moisture, free water retained on surface of aggregates particles and considered to be part of mixing water in concrete, as distinguished from absorbed moisture. Then surface retarder. A retarder applied to conflict. Retarder applied to contact surface. Retarder applied to concrete surface, contact surface of form or to surface of newly placed concrete to delay setting of cement facility and coring. We can stand after that surface bonding and bonding of dry lead masonry, barging, etc. we have done it, and surface moisture we have done it, and surface retarders. A retarder applied to contact surface of a form or the surface of newly placed concrete to delay setting of cement, facilitate construction joint cleanup, or facilitate production of exposed aggregate finish. Surface tension. Surface tension. An internal molecular force. An internal molecular force that exists in surface film of all liquids and affects wetting characteristics of liquid. Internal molecular force that except surface tension, an internal molecular force that exists in surface film of all liquids and affects wetting characteristics of liquid. Surface texture, degree of roughness or irregularity of exterior surface of aggregate particles as well as hardened concrete. Surface vibrator, a vibrator used for consolidating concrete by application of the surface of a mass of realistic vibrator Then we can say surface texture, the surface vibrator. A vibrator used for consolidating concrete by application to surface of a mass of freshly mixed concrete. Four principal types exist: vibrating screed, pan vibrators, plate or grid vibrator dampers, and vibratory roller screed, surface vibrator. Vibrator used for consolidating concrete by application to surface of a mass of freshly mixed concrete. Four principal types exist, and that is vibrating screed, pan vibrators, plate or grid vibrator dampers, and vibratory roller screeds. Surface wise, cavities visible on surface of solids. Surface water, surface moisture, surface active agent. Surface active agent. Surface active agent is substance that affects markedly. A substance that affects markedly interfacial or surface tension of solutions when present, even in low concentrations. Surface active agent is substance that affects markedly interfacial or surface tension of solutions when present, even in low concentration. Surfactant, shortened form of term surface active agent. Sustained modulus of elasticity. Sustained modulus of elasticity. Term including elastic and inelastic effects in one expression. To aid in visualizing net effects of strain curve. So we say, what do you say? It is surface active agent, surfactant. We have here sustained modulus plasticity term including elastic and inelastic effects of one expression to aid in visualizing net effects of stress strain up to whatever given time, computed by dividing unit sustained stress by sum of elastic and elastic deformations at that time. Saw brace, a diagonal brace to resist window or other head. We have then, you can say, sway brace, a diagonal brace used to resist wind or other lateral force, swelling, increase in either length of volume, expansion volume change, autogenous volume change, swirl finish in non-skid, a non-skid texture imparted to a concrete surface. A non-skid texture during final traveling by keeping trowel flat and using rotary motion, and that is swirl finish. Swiss hammer, rebound hammer, preferred term, and cis syngenite, potassium calcium sulfate hydrate. Syngenite is potassium calcium sulfate hydrate. We can then we can say syngenite. Syngenite. It is you can say potassium calcium sulfate hydrate, a compound sometimes produced during hydration of Portland cement, found in deteriorating Portland cement concrete and said to form a Portland cement during storage by reaction of potassium sulfate and gypsum. Syngenite, potassium calcium sulfate hydrate, a compound sometimes produced during hydration of produced Portland cement, found in deterioration of Portland cement concrete and said to form Portland cement drug found during storage by reaction of potassium sulfate and gypsum. System International, everybody knows talc, a mineral with greasy or soapy feel, a mineral with a greasy or soapy feel, very soft, having composition Mg3Si4 O10 OH2, that is TAMP process, a process for producing concrete products. This is pipe that uses direct mechanical action to consolidate concrete by action of dampers and that use rise symmetrically. So we can say what's there, very important, TAMP process, a process for producing concrete products such as pipe that uses direct mechanical action to consolidate concrete by action of dampers that rise automatically as form is rotated and filled with concrete from above. Damper and implement used to consolidate concrete or mortar in molded forms, a hand-operated device for consolidating floor topping or other unformed concrete by impact from drop device in preparation for strike off and finishing. Contact surface often consists of screen. Contact surface often consists of screen or a grid of bars to force coarse aggregate below the surface of prevent interference with floating or traveling. A hand-operated device for consolidating concrete topping or other unformed concrete by impact from drop device preparation for strike off and finishing. Contact surface often consists of screen or a grid of bars to force coarse aggregate below surface to prevent it with force or less. Beam composed of a stem and a flange in form of T. Deltate device composed of a boss. Then we have tamping rod we discussed, now T-beam we have discussed, now deltate we have discussed. Any device designed to indicate movement of formwork or a point on the horizontal surface, pile under load, telltale. Device designed to indicate movement of formwork or of a point on longitudinal surface of a pile under load. Tamper to avoid water to tamper here is to add water to cementitious mixture as necessary to initially bring mixture to desired workability. Temperature cracking due to tensile failure. Cracking due to tensile failure caused by temperature drop in members. Cracking due to tensile failure caused by temperature drop in members subject to external restraints or by temperature different circumstances. Then we have here temperature cracking. It is cracking due to tensile failure caused by temperature drop in member, subject to external restraints or by temperature differential in members, subject to internal restraints and temperature reinforcement. Reinforcement designed to carry stresses resulting from temperature changes. Also maximum reinforcement for areas of members that are not subject to primary stresses or necessarily temperature stresses. Temperature rise. Temperature rise. Increase of temperature caused by the absorption of heat or internal generation of heat, hydration of cement in concrete, you can say, that is rise of temperature. Temperature rise, temperature stress, stress in restrained structure or a member due to changes or differential in temperature in structure or member. Then you can say this is an important point. Temperature rise and it says increase in case of temperature caused by either absorption of heat or internal generation of heat, for example hydration of cement and concrete, and temperature stress in restrained structure or member due to changes in differential in temperature and structure or member. Temperature rise period time interval during which temperature of a concrete product rises at a controlled rate to desired maximum or in autoclave or atmospheric pressure steam curing. Temperature rise period time interval during which temperature of a concrete product rises at a controlled rate to desired maximum in autoclave or atmospheric pressure steam recurring. Temperature time factor, product of temperature multiplied by time, product of temperature multiplied by time for a specified interval. Maturity factor is a temperature time factor in template. A thin plate of board frame. Template, a thin plate of board. A thin plate or board frame used as guide in positioning or spacing form. A thin plate or board frame used as guide in positioning or spacing form parts, reinforcement or anchors. A full-size mold pattern or frame shape to serve as a guide in forming or testing contour or shape. Temporary stress. A stress that may be produced in a we can say a stress that may be produced in a precast concrete member or in a component of a precast concrete member during fabrication or erection or in cast in place concrete structures due to construction or test loading. Tendon, an assembly consisting of a tension member or tension element such as wire, bar, rod, strand, or a bundle of these elements used to impart compressive stress in concrete, along with whatever associated components used to enclose and anchor tension element. Tendon profile, path of trajectory. So we can say tendon profile, tendon assembly consisting of tension elements such as wire, bar, rod, stand, bundle of these elements used to impart compressive stress in concrete along with any associated components used to close and anchor tension element and tendon profile, path trajectory of persisting tendon, tensile strain capacity, maximum tensile strain that hardened cement paste, mortar or concrete can sustain before cracking occurs. Tensile strain capacity, maximum tensile strain that hardened cement paste, mortar or concrete can sustain before cracking occurs. Tensile strength, maximum stress that material is capable of resisting under axial tensile load based on cross-section area of specimen before loading. Tension reinforcement designed to carry tensile stresses such as at the bottom of the simple beam. Ternary mixture, concrete containing three cementitious materials. Terrace concrete, marble aggregate concrete, and that is cast in place or precast and ground smooth for decorative surfacing purposes on floors and walls. Test. A trial examination, observation, or evaluation used as means of measuring either a physical or a chemical characteristics of a material or a physical characteristics of either a structural element or a structure. Test is a trial, examination, observation, evaluation used as a means of measuring either a physical or a chemical characteristics of a material or a physical characteristics of either a structural element or a structure. tetracalcium aluminoferrite. Tetracalcium aluminoferrite, a compound in calcium aluminoferrite series having composition 4CaO, Al2O3, Fe2O3, abbreviated C4AF, that is usually assumed to be aluminoferrite present when compound calculations are made from results of chemical analysis of Portland cement. Texture, pattern or configuration apparent in an exposed surface. Pattern or configuration apparent in an exposed surface. Pattern or configuration apparent in an exposed surface, as in concrete and mortar, including roughness, streaking, striation, or departure from flatness. Texture, pattern or configuration apparent in an exposed surface, as in concrete and mortar, including roughness, streaking, striation, or departure from flatness. Texturing. Process of producing a special texture. Process of producing a special texture on either unhardened or hardened concrete. Thermal conductance. Thermal conductance of a gas, liquid, or solid. A measure of rate at which heat passes perpendicularly through a unit area of material of specified thickness for a temperature difference of 1 degree. Thermal conductance in the gas, liquid, or solid. Measure of rate at which heat passes perpendicularly through a unit area of material of specified thickness for temperature difference of 1 degree. Thermal conductance, a measure of rate at which heat passes through perpendicularly through unit area of material of specified thickness for a temperature difference 1 degree. Thermal conductivity. Thermal conductivity, ability of a homogeneous material to conduct heat, measured as steady state heat flow per unit area through a body of unit thickness with 1 degree temperature difference between surfaces. Thermal conductivity, ability of homogeneous material to conduct heat, measured as steady state heat flow per unit area through a body of unit thickness with 1 degree temperature difference between surfaces. Thermal contraction, contraction caused by decrease in temperature. Thermal diffusivity, thermal diffusivity. Thermal conductivity, divided by product of specific heat and density. Thermal diffusivity, conductivity divided by product of specific heat into reactivity. Thermal, thermal conductivity, as I said, thermal contraction, as I said, thermal diffusivity, as I said, an index of ease which a material undergoes temperature change. So diffusivity is thermal conductivity divided by product of specific heat and density, and thermal diffusivity is also an index of ease with which material undergoes temperature change. Thermal expansion caused by increase in temperature. Thermal movement, change of dimension of concrete or masonry resulting from change of temperature. Thermal movement is change of dimension of concrete or masonry, change of dimension of concrete or masonry resulting from change of temperature. You can say thermal contraction and thermal expansion refer to thermal resistance reciprocal of thermal conductance expressed by symbol R, and thermal shock subjection of newly hardened concrete to rapid change in temperature that may cause surface cracking, and that is thermal stress. And we have see how we now to go to see 5 minutes, come back, put on this back so that doesn't stop. You may stop otherwise. Just a minute now. We have this page 71, thermal volume change, then we have thermoplastic, then thermosetting, thin shell precast, thixotropy, threaded anchorage, tie bar, tie rod, tie back, tight column, tilting mixer. So these are also very important definitions which we have to discuss. Just coming back in a couple of minutes. Linda, hold on please. I'll be back with you. It's now 6:40. Maybe by 6:15, 6:45, I'll be back in a couple of minutes, as usual, to feed birds. Now, sorry gentlemen, I don't know why temperature, fog outside, really heavy fog, and what to say about that. It is fog. Thermal volume change. Thermal volume change. Increase or decrease in volume. Increase or decrease in volume caused by changes in temperature. Increase or decrease in volume caused by changes in temperature, which also relates to thermal contraction and thermal expansion. Thermoplastic, capable of being repeatedly softened, capable of being repeatedly softened by heating and hardened by cooling. Thermoplastic. Thermoplastic, capable of being repeatedly softened by heating and hardened by cooling. Thermosetting, becoming rigid by chemical reaction and not remeltable. Becoming rigid by chemical reaction and not remeltable. Thin shell precast. Precast concrete characterized by thin slabs and web section. Thin shell precast. Precast concrete characterized by thin slab and web section. Thixotropy, a property of a material to thin upon isothermal agitation and to thicken upon subsequent rest. Thixotropy, property of material to thin upon isothermal agitation and to thicken upon subsequent rest. A property, this thixotropy means metal to thin upon isothermal agitation and to thicken upon subsequent rest. If it is real term web, what happens? You can say thixotropy. What does it say? This must be checked because something is unclear here, I think. Thixotropy. Says thixotropy is a time-dependent shear thinning property. Certain gels or fluids that are thick or viscous under static conditions shall flow or become thinner, less viscous, over time when shaken, agitated, shear stressed or otherwise stressed. Time dependent viscosity. So it says thixotropy is a time dependent shear thinning property. Certain gels or fluids that are thick or viscous under static conditions flow, become thinner, less viscous over time when shaken, agitated, shear stressed or otherwise stressed, time dependent. If you see explanation, They then take a fixed time. They then take a fixed time to return to a more viscous state. Fluids show a time-dependent change in viscosity, right? So this is what a thixotropic fluid is: a fluid which takes a finite time to attain equilibrium viscosity when introduced to a steep change in shear state. Some thixotropic fluids return to a gel state almost instantly. Others, for example, such as ketchup, and are called pseudoplastic fluids. Others, such as yogurt, takes much longer and can become nearly solid. This is what is. So I don't explain more than this. I think staff also understand what is that. So understand what's that is important point. So threaded anchorage. Threaded anchorage. I think this page 71, few pages left in this, and we have to understand all. We have to think about what to do with that. If you go to this page, we see there are so many more terms which are also very important, and there is transit mixture, transit mixed concrete, T, and we have good terms, anyway, good one. So type 1, 2, 3, 4, 5 cements, normal, modified. One is normal, modified, high strength early, and low strength and sulfate resistance. So normal, modified, very easy to remember. One is normal, two is modified, third is high strength, and fourth is low strength. High strength cement and low heat cement, and that's so easy to remember. Ultimate moment and all that. Start them, it's better to have them. It will take maybe one day more to go through this and review whole. I think it's a good support to have something very elementary from viewpoint of understanding technical terms. It's to have good review of knowledge. Maybe at the school time we could not do it due to many restrictions, many confinements, but then we come here. So I think it's only 8 pages more, not more than that, and I think it's okay. Means we Should not worry about much. You can say let us say it is 71 page as usual, and that's where we were. Our thermoplastics here. I think we have to be specific about everything, clear or unclear, and it's also very important that we have to come what engineers should do. Should they get up and think of every issue, which is very important from every point of view, cannot be disregarded, have to tolerate all this in a way, have to understand, should go to some in-depth crop knowledge, like titles as given here. I repeat, we started with quality, concrete specifications, civil field engineering, life, engineers, and then of course AnnexSL, red, silver, white books, and we have here designs, construction, methods, contracts, disputes, organizations, communication, coordination, and why, quality of materials. This is actually kind of sharing information, extracting information, dissemination required in profession, which constitutes very important part of profession. I understand there should be no declination but inclination. Engineering, everybody knows, is unlimited field. No one can cover whole engineering in one's life. Even one branch of engineering, civil engineering, is so vast that I can't even think of just one discipline to go through thoroughly. And because life has been engineered, life has been engineered to engineering, you can say life has been forced to engineering. If we think today, imagining ignore engineering, well, I think that's not going to happen. That cannot happen. We cannot ignore engineering. It is impossible. If somebody thinks that one can ignore engineering, I should say that it is self-denial. It is, self-deception. We can't do that. Even after having many years of experience and trying to understand. Every day I feel I have little knowledge. Even if I go through all these documents, all this learning, all my talks, your knowledge, every day I think I know nothing. Hmm? I mean, mind is, you can say, trying to a level when you don't feel that you know something, right? Because everything looks as norm. I don't feel I know something, as if life has been accustomed to engineering. We have to understand this point very well. And we keep up on this in coming times. We keep this in coming time and trying to know more and more from such documents which can help us in our professional callings. I am open to every subject, to every interdiscipline question, and of course contracts are very important as far as construction and designs are concerned. Contracts and contract disputes, without which we cannot do anything. In engineering world, contracts are very important. And when these are important but we are not so serious about them, it's not necessary that you have to know law first, not necessary. First you have to know engineering and engineering methods, because if their disputes erupt, it's only because of negligence somewhere, not because of law. That point you have to understand. If law is very simple, to be very frank. Reason being, law does not involve any mathematics. Law does not involve any science theory, any engineering theory. It is only a kind of scare that we have in our minds that I do not know law, we do not know law. No need, don't worry, method is important. And that's the only reason in disputes resolution mechanism, civil procedures do not matter. What matters is logic. What matters is contract. What matters is national law. What matters is constitution. Or you can say preliminary knowledge only, not specific knowledge. Yes, specific knowledge of applicable codes like you can say arbitration act, or you can say some technical acts which we know. For us, whole engineering is like law. Every code is law, every method is law, convention is law, all for us is law. So we have to be very logical in this regard. It is very easy to understand. If we can understand engineering, we can work on engineering, we can design engineering, we can field engineering, or you can say we can work in designs, we can work in fields, we can respond to millions and trillions and billions, we can take responsibilities of material, human resources, machines, every. Why can't we do on something that relates to our job? First of all, why should dispute appear? Why should, what reason being there is appear? That is what we have to understand. And what way we have to mitigate those disputes, that also we have to understand. That means somewhere we miss something, engineers miss something, and that is in communication, that is in writing, or that is in certain documents that we ignore, or we do not coordinate properly even composition of documents, production of documents. And we leave something somewhere and we do not want to review and fill up. And when work comes in, we do not do complete documentation work. That also leaves room for others to pinpoint and okay, oh, it's missing. And law people, they always try to skin out, extract skin from here itself. But that's not a question here. Question here is workability of contract. Just like we say workability of concrete, I can say workability of contract, work applications of contract, power of applications of contract. All those are very important factors which we cannot deny, and we should not deny because these are very important ones. It's always easy to say something, but one should be clear in approach. That is very important point. And if we cannot be clear in approach, nothing can be done. These points, as I put in topic, are all relevant to engineers. Even if you are design engineer, you are a practical construction engineer, or you are a consultant, or you can say even a contractor or a advocate you are, even a judge you are, involved in arbitration or involved in contracts, or you may be whosoever. These talks help everyone from budding engineer to veterans, because these are not just book oriented talks, these are experience based talks. It has been my habit to think on what I did mistakes, what I did right in my experience. Every lesson teaches you, every act teaches one. Maybe I am wrong somewhere. I cannot claim I am right everywhere. We have to digest these facts. But what we think now, that is important. Concentration requirement is very important, which we miss today. And that is what, just like without concentration, we cannot communicate properly, we cannot coordinate properly. Peace of mind, stability of mind, and power of thinking have to take together. That is what we have to understand very well. With this, we will continue next time. I hope you got something out of this, I am sure. And that's what I say. We have to be sure all time. We have to be again mover. We have to move together, and we'll see you if everything goes fine because of scares of COVID everywhere. Thank you very much. Take care.